Hello, my Math 3 scholars. Today in this video, we are going to introduce you to exponential functions. This is new. You probably have not done it before, but I would like to remind you about what an exponent is. So, for instance, if I ask you to evaluate 2 cubed, that means you would write down the number 2 3 times, and you would multiply it. So that would be 2 times 2, which is 4, times 2, which is 8, okay? So that's just a review of what an exponent is. So to introduce you to exponential functions, an exponential function, first I'm going to define it for you. An exponential function has the form y equals ab to the x power, where, now these stipulations are very important. A cannot be equal to 0, because if a is 0, then this whole thing would be 0. Okay, so you wouldn't have an exponential function. So a can't be 0. B has to be greater than 0. So b can't be 0 and it can't be a negative number. So our b has to be greater than 0. And our b cannot be equal to 1. So it's got to be a number greater than 1, because, of course, if it was a 1 here, if we raise 1 to any power, we're just going to get 1. So a times 1 would just be whatever this a is, and we wouldn't have an exponential function, okay? So these stipulations that you are given here are very important, so you may want to highlight those. A cannot be equal to 0, B has to be greater than 0, and B cannot be equal to 1, okay? All right, so we also need to learn, and I talked a little bit about this year, but we need to learn about an asymptote. An asymptote is a line that a curve approaches as it heads towards infinity. In other words, the graph never touches the asymptote. The graph will never touch the asymptote, okay? Never. That's a key thing there, okay? So it's almost like you would have a graph over here, like this, okay? And we would have a graph that might come down like this, and it might continuously approach this this y line here of y equals 0, but it would never touch it. So our asymptote here would be the line y equals 0, okay? All right. Now, I'm going to give you some properties of exponential functions, okay? So one of the properties of exponential function is that the function is continuous. Okay, the function is continuous. That means it never stops. It goes all the way to negative infinity and all the way to positive infinity. Okay, the function is continuous. And the function is also a one-to-one function. One-to-one, I will remind you, means that for every input value of x, you have a separate output value of y. So every x has its own unique y. Okay, all right. The domain of all your exponential functions is always going to be negative infinity to positive infinity. Will always be that. Your asymptote of the graph will always be your x-axis. The x-axis is the asymptote of the graph. The range is the set of all positive numbers if a is greater than 0, and it's all negative numbers if a is less than 0. Okay? So if a is greater than 0, it's all negative numbers, and if a is less than 0, it's all positive numbers. And your graph will always contain the point 0a. Will always contain the point 0a. So whatever your a value is, you can be guaranteed that a point on your graph is going to be 0a. All right. So we're going to talk about two types of exponential functions. Okay, we're going to talk about two types. The types we're going to talk about are growth and decay. Growth and decay. Now, here's how you're going to know whether or not you have a growth or a decay function. If a is greater than 0, so let's highlight this. If a is greater than 0 and b is greater than 1. If a is greater than 0 and b is greater than 1, then the function y equals ab to the x, your exponential function, is going to represent an exponential growth. For example, you might have a function that's like this, 3 times 1.5 to the x power. That would be my a is greater than 0 and my b is greater than 1 because it's 1.5. So that's a growth, an exponential growth. Okay? If a is greater than 0 and B is between 0 and 1. So my B is now between 0 and 1. Then my function y equals a b to the x is going to represent an exponential decay. For example, we might have something like 2 times 1/4 to the x power. Notice that that 1/4 is a number that is between 0 and 1. Okay, that's a fraction that's between 0 and 1. Therefore, we have a decay. So basically, if you notice over here, this stipulation is the same, a greater than 0. So you're basically looking at your b to tell whether or not you have a growth or a decay. Okay, so if b is greater than 1, like here, you're going to have a growth. And if b is between 0 and 1, so it's a fraction that's a fraction between 0 and 1, like here, 1/4, then you're going to have a decay. All right, that's to introduce exponential functions. In the next video, we'll look at graphing them.